Alright, let's look at the homework 11.6, problem number 10. Alright, so let's apply ratio test to the following series. Alright, so let's look at part A. So let's look at the limit as n approaches infinity. Absolute value of an plus 1, so it's going to be 4 over n plus 1 cubed. Alright, then multiply by the reciprocal of an, which is that. So I'm just going to put it upside down. So n cubed over 4. Alright, then we can cancel 4 on top here and a 4 on the bottom. Alright, then I'm going to write this guy as, so since they're cubed on top and bottom, so I'm going to write the cube once. So this is going to be a limit of n over n plus 1 cubed. And absolute value sign is not necessary because everything is positive anyway. Alright, so I'm going to squeeze this limit inside the cubic function here. So this is going to be, so I'm going to just go ahead and take the limit of n over n plus 1 first, then raise it to the third power. Alright, since it's going to go to infinity over infinity, so I'm going to apply L'Hopital's rule here. So you have a limit as n approaches infinity. Derivative of n is 1 with respect to n. Derivative of n plus 1 is 1 as well. So limit is going to be 1. And then we raise it to the third power. Alright, so 1 cubed is going to be 1. Alright, so in this case, since the limit came out to be 1, this is going to be inconclusive, unfortunately. Alright, so let's type that in. So it's inconclusive. Alright, so let's look at the part B. Alright, we're going to do the same thing. So you have a limit as n approaches infinity. Absolute value of an plus 1. So I'm going to put the n plus 1 over 2 to the n plus 1. Alright, then divide by an. So I'm just going to take the reciprocal and multiply. Alright, so let's simplify here. So we can cancel 2 to the n here. And you have a 2 to the n plus 1, so I'm going to just scratch the power. So we still have 2 on the bottom. Right? So what we can do is I'm going to pull out the 1 over 2 outside. So that takes care of 2 on the bottom. Right? Then we have a limit. And again, I'm going to just remove the absolute value sign because nothing is really negative. So I'm going to do n divided by n is 1 plus 1 divided by n is 1 over n. Right? As n approaches infinity, we know that here, this guy approaches 0. Right? And this is going to be equal to 1/2. Right? Which is strictly less than 1. Therefore, this tells you that it's going to be a convergent series. Right? So part B is conclusive and it's convergent. Alright, so let's look at the part C. Alright, part C, we do the same thing. So a limit as n approaches infinity, absolute value of, right, so n plus 1, so it's going to be negative 3, raise it to the n plus 1 minus 1, so it's going to be just n, over square root of n plus 1 divided by an. So we just take the reciprocal. So you have a square root of n over negative 3 to the n minus 1. Right? Then we can cancel. Right? So you have negative 3n minus 1. So cancel with that. And I'm going to scratch n, but we still have a negative 3 left over. right? But with the absolute value sign, -3 becomes +3. So I'm going to just pull out the +3. So that will take care of this guy, right? Then we still have to take the limit. So limit as n approaches infinity, right? So both of these guys have square root. So I'm going to write the square root once. And you're going to get the square root of, right, n over n plus 1, right? So what you can do is, again, we can squeeze this limit inside the square root sign. So this is going to be 3 times square root of the limit as n approaches infinity and n over n plus 1. We actually did this exact computation up here in part A. The limit was going to be 1, so I'm going to use that. So this limit is going to be 1. So this tells you that this limit, the whole limit, is going to be 3 times 1. So it's going to be 3, which is strictly greater than 1. This tells you that the series is divergent, right? So let's type that in. So it's divergent there. All right, the last one, same thing. We take the limit as n approaches infinity, right? So n plus 1, so you have a 3 square root of n plus 1 over, right? So you have a 1 plus, all right, n plus 1 squared. So I'm gonna go ahead and multiply. Actually, I'm gonna just keep it n plus 1 squared. How about that? All right, then here you're gonna have so reciprocal of that, 1 plus n squared, and 3 square root of n. All right, so I'm gonna combine. Let's see. Square roots together. Actually, before that, we can cancel 3 on top and the 3 on the bottom, right? Then what we're going to do is I'm going to combine the square roots together. So you have n goes to infinity, right? So you have a square root there and a square root there. So I'm going to put the big square root, right? Then you have n divided by n. I'm going to write 1. Plus 1 divided by n is 1 over n. Right, so we got that. And then the rest is going to be here. So you have a 1 plus n squared. So times 1 plus n squared. And on the bottom, if you multiply out, so this part is going to be n squared plus 2n plus 1. So this is going to be, I'm going to combine 1 and 1, so that becomes 2. So n squared plus 2n plus 2. All right, then, to take the limit, I'm going to actually divide the top by 1 over n squared, divide by n squared, and the denominator by n squared. All right, so this is going to give us a limit as n approaches infinity. I'm just copying this part, 1 plus 1 over n. This here, 1 divided by n squared would be 1 over n squared. N squared divided by n squared is going to be 1. And n squared divided by n squared is 1. 2n divided by n squared would be 2 over n. And 2 divided by n squared would be 2 over n squared. Right? So you can see that here, this guy approaches 0. That guy approaches 0. And that guy approaches 0. And also that guy approaches 0. Right? So you can see that everything is actually going to 1. So this is going to be 1 times 1 over 1. So it's going to be 1. Which means that unfortunately this ratio test is inconclusive. Right, so let's type that in. D was inconclusive. All right, so let's submit for testing. All right, it came back and looks like we got all of them correctly. All right, that's it. I hope that this was clear.